Welcome. I'm Ramya Devi, working as Assistant Professor in Computer Science and Engineering Department at Hindustan College of Engineering and Technology. In this video, we're going to see the topics related to computer networks. So we'll be concentrating in layering and protocols, example of layered network systems, service and peer interfaces, examples of a protocol graph, encapsulation, multiplexing and demultiplexing, OSI 7-layer model. So layering and protocols, first we need to understand what is abstraction. So abstraction, it is nothing but hiding the details of implementation. So it's a well-defined interface. It is a fundamental tool used by system designers in order to manage complexity. So the idea of abstraction is to define a model that can capture some important aspects of the system. So we can able to encapsulate those things as an object, which will be providing an interface that can be manipulated by other components of a system, so that we can able to hide the details of implementation in the user's perception. Abstraction, naturally, it will be leading to layering, especially in network systems. So the service provided at higher layers will be implemented in terms of services provided by the lower layers. So if we have a simple network having two layers of abstraction between the application program and underlying hardware, we'll have process-to-process channels and host-to-host connectivity. So the lower layer provides host-to-host connectivity, which will be abstracting the fact that there may be a complex network topology between two hosts. The next layer will be building a host-to-host communication service and provides support for process-to-process channels. It will be abstracting the network occasionally which loses messages, for example. So layering, it provides two main features. The first one, it decomposes the problem of building a network into more manageable components rather than implementing a software which does everything. The second one, it provides a modular design. If you decide that you want to add some new service, you may only need to modify the functionality at one layer so that we can able to reuse the functions provided at all other layers. So many times there will be multiple abstractions provided at any level of the system. So this is an example where we have two types of channels, request reply service and also message stream channel. So these two channels might be alternative offerings at some level of a multi-level networking system. Request and reply is one of the basic methods computer use to communicate with each other in a network, in which the first computer will be sending a request and the second will be responding to the client's request. The best example is web client and server. The web client, you will be using a browser in order to send a request, and the server which will be responding to the client's request. So a stream is nothing but a chain of coroutines that pass messages between a program and a device driver. So abstract objects that make up layers of a network system. So these are called as protocols. So protocol will be providing a communication service that higher level objects use to exchange message. For example, we could imagine a network that supports a request reply protocol and a message stream protocol, so that both these things will be defined using two different interfaces. One is service interface, another one is peer interface. So the service, both the things will be defining a service interface to the other objects on the same computer that want to use its communication service. So this service interface will be defining the operations that local objects can perform on a protocol. So for example, a request reply protocol would support operations by which an application can send and receive messages. So the protocol will be defining a peer interface to its counterpart on another mission. So this second mission defines the form and meaning of a message exchange between protocols, peers, to implement the communication service. So this is an example. We have two hosts, host 1 and host 2. With the help of protocols, these two systems will be connected. So irrespective of the hardware or software, used by both the systems, they can able to communicate with each other. Why? Because with the help of a protocol. So it may use a Windows operating system and a 32-bit processor, and this may use a Linux operating system with 64-bit processor. Both are irrelevant, even though these two machines can communicate with each other with the help of a protocol which is being connected. So the protocol, it defines a communication service that it exports locally, along with a set of rules governing the message that the protocol exchanges with its peers to implement the service. So except at the hardware level, where peers directly communicate with each other over a link, that is peer-to-peer communication, is indirect. Each protocol communicates with its peer by passing messages to some lower level protocol, which in turn delivers a message to its peers. So there are potentially multiple protocols at any given level, each providing a different communication service. We'll see an example for that. So this is an example where there are 3 layers, and each and every layer uses different protocols. So this protocol graph, it is for hypothetical layered system which we have been discussing. So the protocol RRP, that is RRP is nothing but request reply protocol, and MSP is nothing but message stream protocol. So these two implement 2 different types of process to process channels, and both depend on host to host protocol, that is HHP, which provides a host to host connectivity service. Suppose that the file access program on host 1 wants to send a message to its peer on host 2 using the communication service offered by RRP. In this case, the file application, it will be asking the RRP to send the message on its behalf. So through this way, the message will be reaching the destination. So to communicate with its peers, RRP will be invoking the service of HHP, which in turn transmits the message to its peers on the other machine. So this is the actual way the message which will be passed to the host 2. So that the term protocol is used in 2 different ways. Sometimes it refers to abstract interfaces, that is the operations defined by the service interface and the form and the meaning of a message exchanged between peers, and sometimes it refers to the module that implements 2 different interfaces. So now we'll see what is encapsulation. So encapsulation, when one of the application programs sends a message to its peers by passing the message to RRP. From RRP's perspective, the message it is given by the application is an uninterpreted string of bytes. So RRP does not care that these bytes represents an array of integers, whether it represents an email message or a digital image, whatever. It's simply charged with sending them towards peers. However, this RRP must communicate control information to its peers, instructing it how to handle the message when it is received by the host 2. So RRP does this by attaching a header to the message. So this is the application program. It sends the data. So this data is taken by RRP. RRP will be adding its own header, and it is sending to the next HHP. HHP in turn, it will be adding its own header. So with the help of link, so this is the HHP header and this is the RRP header. Once it is reached by the network interface card, so this message will be taken, and when the data is given to the next layer, the header attached by HHP will be removed, and only the payload part will be handed over to the next layer. In turn, RRP, it takes out its own header and it is handing over the data alone, that is payload part, only to the application program. So the process of encapsulation is then repeated at each level of the protocol graph. For example, HHP will be encapsulating RR's message by attaching a header of its own. So this is how the message will be taken from one host and it will be given to the next host. So next we'll see multiplexing and demultiplexing. A fundamental idea of packet switching is to multiplex multiple flows of data over a single physical link. So this same idea applies up and down the protocol graph, not just to switching nodes. So example, we can think of RRP as implementing a logical communication channel with messages from two different applications multiplexed over this channel at the source host and then demultiplexed back to the appropriate application at the destination host. So particularly speaking, the header that RRP attaches to its message contains an identifier that records the application to which the message belongs. So we call this identifier RRP demultiplexing key or DMUX key for short. At the source host, RRP includes the approximate DMUX key in its header. When the message is delivered to RRP on the destination host, it will be stripping its header and examining the DMUX key and demultiplexes the message to the correct application. So RRP is not unique in its support for multiplexing. So nearly every protocol implements this mechanism. So there is no uniform agreement among protocols, even those within a single network architecture, which will be having a DMUX key, different DMUX key. Some protocols use a 8-bit field and some other uses even 64-bit keys or 32-bit fields, or even high-level protocols, they'll be using 256 keys. Some protocols have a different demultiplexing field in their header, while others have a pair of demultiplexing fields. In the former case, the same DMUX key is used on both the sides of communication. So we have discussed layers and protocols in this video, and also we have discussed encapsulation. What is encapsulation? How multiplexing, demultiplexing is done, and also we have seen an example of protocol layer, protocol graph actually, and also we have discussed OSI 7-layer model. Thank you.